Good morning, and myself Shubhangi Napini, and I'm going to present my topic about vector processor. So first of all, we can see the content of the vector processor. Here is the content like definition, features, work, memory in vector, vector instruction, and other. So first of all, we can see the what is the vector processor. Vector processor is do certain operation in memory or CPU. Like vector processing is a central processing unit that can perform the complete vector input in individual instruction. Complete unit of hardware resources that implements a sequential set of similar data elements in the memory using an individual instruction. And the scientific and research computation involve the many computation which require extensive and high power computation. And then uh, here is the vector processing diagram, which we can individually and see in the memory. And here is the feature of vector processing. A vector is a structured set of elements. The element vector often include an ordered set of elements that is known as the length of the vector. Each clock period process two successive pair of elements during a one single clock period. The dual vector pairs and the dual sets of vector functional units allow the processing of two pairs of elements. In the parallel vector processing, more than two results and generated per clock cycle. The parallel vector operands and automatically started under the following two circumambulation when the successive vector instruction facilitates the different function unit and other pipeline unit in the vector register. And here is the working and architecture, how it's work. So vector processing have the vector instruction which operate on the large array of integer or floating point number. And IPU, intelligent processing unit, is the convert to the main code in the understanding language. This is the IPU or instruction processing unit vector register, which we can see in the memory, how it's work, scalar register, scalar processor, vector instruction controller, vector access controller, vector processor. And here is the overall working, how it's working. As it has a several functional types, so it can execute the instruction over the operand, the instruction processing unit, like intelligent processing unit instruction from the memory. Once the instruction is fetched, then IPU determine either the fetch instruction is scalar or vector in nature. And if it is scalar is nature, then the instruction is transferred to the scalar register and the further scalar processing performed. While when the instruction in a vector nature, then it's vector instruction controller. This vector instruction controller first decode the instruction and accordingly determines the address of the vector operands present in the memory, and then give a single of vector access control about the demand of the respective operand. This vector access controller then fetched the desired operand from the memory. And at that time, when multiple vector instructions are present, then the vector instruction controller provides the multiple vector instruction of the task. And then the working in the successful. And this is the classification vector processor. There are the two type of classification. First of all, register to register architecture, and second one, memory to memory architecture. In register to register architecture, highly used to vector computer. As in this architecture, the fetching of the operand or previous result indirectly takes place to the main memory by the use of register, and then several vector pipelines present in the vector computers help in the retrieving of the data from the register and also storing the result in the desired register. This vector register use the instruction programmable. And the second one is the memory to memory architecture. In this in the memory to memory architecture, operand or the result are directly fetched from the memory despite using the register. However, it's not be noted here that the address of the desired data to be accessed must be present in the vector instruction. This architecture enables the fetching of the data of size 512 bits from the memory or pipelines. However, due to high memory access time, the pipeline of the vector computer required the higher type of instruction. And here is the vector in memory, how it's work. There are the five type of hash 0, 1, 2, and 3. The first of all, uh, assign to send the instruction to the hash, and hash convert to the 1, 2, and other instruction for the vector processor and unit and using the vector register. Here is the control unit memory and uh, how pipeline using the using the pipeline, how it's converted to the instruction program. Here is the vector instruction. Instruction available depends on the what is the component the vector contains. For a case, we take the VMIPS processor developed in the 2001. Vector microprocessor is developed in the 2001, and floating point multiply, floating point divide, floating point add the instruction, and we can doing the very logical operation like shift right, shift left, and other operation. And yes, here is the instruction diagram. And then we can see the vector performance. Vector execution time depend on the length of operand vector, data dependency, structural hazards, and initial rate. And then the convoy, set of vector instructions that can begin execution in same clock. Like in the clock, the data dependency on structural has seen all the instruction in a convey begin execution at the same clock period. And in approx time it will execute the convey. And here is the example like how we can execute the vector processing. Like 8086 we can we can write the assembly code in the EMU. So how we can write the assembly code? Like here is the variable L1 V1 Rx, and we can load the vector X into the LV. Here is the time duration, which time duration and how many time duration its example and its program will be executed. Here is the advantage of the vector processor. Each result is independent of previous result, following high clock rates, and the single vector instruction perform a great deal work, meaning less fetch, which is in fewer branches, and the vector instruction access memory a block at a time, which result in very low memory latency. Less memory access is equal to faster processing unit, lowest cost due to how and low number of operation compared to the scalar computation, and some disadvantage or drawback of the vector processor. Work well only with data that can be executed is a highly or completely parallel manner, needs large block of data to operate on the be efficient because of the recent advantages, increasing speed of the access in memory, and several lacking of performance compared to the normal process or scalar data, high price of individual chips due to limitation or non-chip memory. Here is the other disadvantages, and here is the conclusion. How and what and how we can use the vector processing over the other processor, and which we can use in the real life. The vector processor is faster the performing mathematical operation or larger vectors. The vector processing computers vectors register architecture make it better able to computer wise amount of the data quickly. While vector processing is not widely popular today, it still represents a milestone in the supermarketing architecture. And the since color processing design can also be used to general application, their cost per unit is reduced. Many other costs, such is not the case for a vector processor supporters. And here is the conclusion of vector processing. Thank you, ma'am.